Welcome to the moon, everyone. Today we're going to be talking about this little satellite of Earth that we sometimes take for granted. I actually wanted to do this in a two-part video where in the first part we're going to try to recreate the moon from scratch, and let's actually talk a little bit about the hypothesis on how the moon was formed. And in the second part we're going to talk about other really interesting facts and tidbits about this really cool, really large and really scary looking satellite of Earth. Welcome to What the Math. And so in this first part, we're actually going to try to talk about something called giant impact hypothesis, or just general idea of how this thing was formed a long time ago and why Earth has such an unusually large satellite compared to other terrestrial bodies. So one thing you may know is that Venus doesn't actually have any moons, neither does Mercury, and Mars, if you look at it, here's Mars. Mars has two really tiny moons called Phobos and Deimos, and they're like really small. They're only about 11 and 6 kilometers in radius, which is tiny in comparison to our moon. Our moon is gigantic in the relation to these satellites. If I actually place the moon here, watch what happens. So this is our moon, and this is really tiny Phobos and Deimos being completely thrown out of their own orbit by the extremely large moon that's actually not very far off in terms of size from Mars. And here comes the first one. I think that was Phobos. Phobos is down, and actually in terms of size, Moon is about 1700 kilometers in radius, and which is about 1200 miles, and Mars is less than twice than that. It's only about 3400 kilometers. So if you change this to moon radii, it's only about 1.95, or almost twice as large as the moon. So in a sense, you could actually call Moon a planet. Some scientists actually refer to Earth and the Moon as the dual planetary system. So in a sense, for a satellite, for an actual moon, this is a very large object. So anyway, so let's talk about its formation. And so what we're going to do is we're going to start a completely new simulation, and we're going to place a terrestrial object and just a random rocky planet right here. We're going to change its size to about 0.9 masses of Earth, so it's going to be about 73 times the moon. And what we're going to do is we're going to launch an object at it, and that's because this is what the theory actually stipulates. According to this theory, sometime a long time ago, about 4.5 billion years ago, or approximately 30 millions after the solar system started to form, our original Earth, let's call it proto-Earth, the Earth that just recently formed orbiting the Sun, had a small collision. And when I say small collision, it was a smaller object, but it was a very large collision. Now, we still are not exactly sure how exactly it happened, specifically what speed the object was traveling at, and what angle of approach it had. But a lot of scientists think that it did happen, and it was an object that was about size of Mars, maybe about a little bit smaller than Mars. Some people suggested it was maybe about only half the size of Mars, but it was Mars-like. And so what we're going to do is we're going to actually smack it at a velocity of about, let's just say 4 kilometers per second. So one of the hypotheses suggested it was about a 45-degree angle, so around right here, and the velocity was under 4 kilometers per second because it came from behind of Earth and it smacked right there. Boom. And so this is what may have happened. Now, you'll notice that most of these objects don't really stay in orbit. They actually, all of them collapse back to Earth. And we're going to do this a few times until we have something forming in the orbit around Earth, something that looks like a satellite. So let's try this again. And this is actually my 10th attempt of doing this at different sort of angles at the speed of 4 kilometers per second. And you'll notice that every time I do this, because of the relatively big mass of the original object, either these fragments fly away into space or they end up crashing back onto the surface. So it's very likely that because we don't really know what the exact speed of the object was when it crashed into original Earth, proto-Earth, it may have been actually going faster. So let's try this again, going a little bit faster this time. This is actually one of the hypotheses proposed by scientists from Harvard. And what they suggested was that it was actually an object going a little bit faster, possibly speeds of up to 12 kilometers per second, and smacking somewhere right here, somewhere along the side of the Earth. So here's attempt number, I don't even know anymore, I think it was like attempt 12. And okay, so watch that. So notice how the fragments do stay a little bit longer around our planet. And if I keep doing this over and over, at some point, one of these objects is going to start orbiting around our planet. And I'm going to do this a few more times just to show you, because every time I do this, after about 10 attempts, there's at least 2 or 3 tries that I get when I'll have this permanent fragment orbiting around the Earth. And this is attempt number 4, and you'll notice that this is actually one of the things that did happen. So we had these particles orbiting around our original planet, Proto-Earth, after the collision, and most of these particles were formed because things like silicates, things like rock, at high temperatures they actually evaporate, and they did escape into the outer atmosphere and essentially into space, and started orbiting around the planet along with other fragments as well. And this is my 10th attempt at this high velocity, so I'm going to try this one more time to basically launch an object at a relatively high angle and see what happens. And the problem with such a high angle and such high velocity is that it would very likely change the orbit of our planet and probably throw it off into a relatively difficult to maintain orbit. It might actually be a little bit more elliptical than it currently is. So I'm not exactly sure if it was possible for an object that is relatively large to collide with our planet and to create a moon, while at the same time maintaining a relatively circular orbit that Earth currently has. So let's try this one more time, but we're going to change the parameters just a little bit. So we're going to place a large rocky planet here and collide it with a somewhat smaller rocky planet going at a speed of about 7 kilometers per second. Now, I'm not going to aim this high up. I'm going to aim somewhere closer to the middle, and this means that this planet may have approached Earth at a slightly higher speed, but somewhere along the middle here. Alright, that was not the best collision in the world. Let's try this again. I'm going to redo this from scratch. And we're going to launch it right in the middle from a slightly further distance. And here we go. So this is the object approaching Earth. And fragments here move a little bit slower, which already gives me an idea that it's going to be a little bit easier to create a satellite this way. So I'm going to try this over and over until I finally succeed at creating a stable satellite around the terrestrial planet that I'm basically placing here randomly. And because it's taken me so many tries, what this may suggest is that the fact that our planet has such a large moon and such a stable orbit is actually a relatively rare event. And I think I may have just created a satellite that has an elliptical orbit. Let's see if this works. Oh no, it's smacked down to us. But yeah, so the fact that we do have a moon of that size and that it orbits so stably around our planet is actually, it's quite a unusually lucky thing to have. So let's try this again. This is, I think I've done this like maybe 20 times now. And usually what happens is most of the objects just kind of collide into our planet. And while I'm trying to recreate this stable satellite around the planet, let me just talk a little bit more about the actual hypothesis and the creation of the moon in general, what we know, what we actually discovered, and why we think this is what happened a long time ago. So firstly, when the collision occurred, it very likely took anywhere between 1 month to about 100 years for all of the material flying around our planet to actually solidify into a spherical object that then became the moon. So it didn't actually take that long for the moon to be formed after the collision. Also, the original object that collided with Proto-Earth had a name, and this is a name that we started to call it in all of the hypotheses, and the name was, of course, Theia. Theia is the Greek goddess that gave birth to the moon. So Theia, oh, I think I renamed the wrong planet. This is supposed to be Theia, and the other planet is supposed to be Earth. And both of them were kind of planets. You could kind of call them planets. And we think that Theia actually came from a similar orbit to Earth and was very likely formed in the same region as Earth, and may have even been orbiting in a very similar plane of orbit at something called Lagrange point. Here's a picture of a Lagrange point. This is what it looks like. And then with time, it just lost stability and then smacked into Earth, thus creating the orbit, sorry, not the orbit, but the orbiting object around it, which then became the moon. And there's quite a lot of evidence to support the fact that basically Earth and Moon were formed from the same sort of molten object that then separated into two pieces. And there's actually quite a lot of evidence to support the collision and the fact that Earth and the Moon at some point were one big molten object. And some evidence basically is that, well, firstly, Earth's spin and Moon's orbit have very similar orientations, and that's quite unusual unless they were created from the same sort of orbiting, spinning object. Also, the moon samples, moon rock samples that we brought from the Apollo missions indicate that at some point Moon had a molten surface, and the age of that molten surface is very similar to the age of molten surface of Earth. And the other thing about the sample is that they have a very similar oxygen composition to the rocks on Earth. In other words, Moon rocks and Earth rocks are actually not that very different, but the other rocks, specifically samples from other asteroids or different asteroids that landed on our planet, they do have a very different composition. They're a lot more foreign in comparison to Earth and the Moon. And what this suggests is that at some point, both Earth and the Moon were actually mixed together in one sort of molten bowl, and they then separate into two different pieces. But the original theory of Moon's creation was actually a little bit different, and it was actually proposed by a scientist in the 19th century. I believe it was 1892 when, or 1898, sorry, when George Darwin, the son of Charles Darwin, the same guy who basically proposed the theory of evolution. So his son was actually an astronomer or astrophysicist, and he proposed that a long time ago when the Earth was hot and molten and really young, because it was spinning so fast, and you can see it spin here, because of its spin, the centrifugal forces threw out sort of a layer from the surface, and that layer then started orbiting around Earth and created the Moon. Now, this particular hypothesis is actually still kind of accepted by some scientific communities, but it just doesn't prove enough, or doesn't show enough about the Moon's composition, and specifically about the fact that it does have some iron on the inside, and if this was sort of the way the Moon was created, it would not really have any iron, because all of the iron is actually inside the planet. It wouldn't be on the outside. And I think this is actually one of my first successful attempts, and here I actually have two moons, which brings me to my other, one of the other tidbits I wanted to talk about. There is a hypothesis that at some point we did have two moons, and both of them were in the same sort of orbit, and because of the way that the orbits progress and evolve, the smaller moon at some point just kind of pancaked, or essentially just landed on top of the main moon, and it landed on the far side. And this would actually explain why the far side of the moon has such a different shape and such a different composition, and just in general it looks very different from the front side of the moon that is facing our planet. If you ever look at the pictures of the far side of the moon, it actually does look like something just kind of landed on top of it on the surface. And so the theory is that there was an object that was about 500 kilometers in radius, which was obviously several times smaller than the moon that we have right now. And at some point, that smaller object landed on the surface, or on the far side of the larger moon, and combined into one. Now let's try this again. I'm going to show you how I did this. We're going to try to create a slightly larger fragment, actually, just to see if we can create a larger, more realistic moon. So we're going to go into the new simulation and add a random terrestrial planet, a random rocky planet, that is. We're going to place it right here. I actually was using just Mars for launching purposes, and it's a little bit smaller than this planet. And I'll launch it at 20 kilometers per second, and just launch it at this area right here. And let's see if something occurs. Okay, we actually were able to create a much larger planet called Mars. It didn't even actually combine into one. This time, actually, this is even a little bit more realistic. It's sort of just passed by the planet and scratched its surface, releasing a lot of fragments and then flying away into distance. Now, there is a hypothesis that says that maybe this is what happened. Maybe the object just kind of scratched the surface, a lot of fragments flew out in the outer area, and then this particular object settled as the moon. So maybe this is how the moon was formed, but most scientists don't think it happened this way. Most scientists think that when the object did collide, the moon and the original, or not the moon, but Theia and the original Earth combined into one. Okay, I actually accidentally released it again, but here we go. Combined into one, and then as they were sort of one big molten lava thingy-majiggy, a lot of the various objects, a lot of the various rocks started flying into the outer regions of Earth right here, and then these essentially just coalesced and combined into one large object that became the moon. Now, you'll notice that I have at least 3 fragments this time orbiting around my original planet, and all these 3 objects at some point will settle into a relatively stable circular orbit similar to the moon. And the original collision hypothesis was proposed by someone called Reginald Ellsworth Daly. And see, it's a kind of a difficult name to remember. You can just maybe try to remember Professor Daly. So Professor Daly proposed that there was a collision which essentially created these fragments that started orbiting around our planet. And at some point, they sort of combined into one large object that is the moon today. Now I'm going to do this one more time, and I just want you to look at something else here. So notice how as soon as I collide Mars into this object, most of the fragments actually fly out. And most of the fragments don't actually even stay in our orbit. They fly into the outer regions of space. And this kind of suggests that many of these objects are still somewhere out there. As a matter of fact, it's very possible that the remains of this Theia Earth collision are still somewhere in the outer space and maybe have even been captured by other planets or other objects into their orbit. So, for example, Phobos and Deimos, which were or are the 2 moons of Mars, are, for all we know, possibly these fragments. Maybe one of them was captured by Mars and became and they became its natural satellite. So it's very likely that these fragments are still somewhere out there, and if one day we find out where they are, or if we can actually discover one of them, we might be able to finally prove the hypothesis for the collision between Theia and Earth. And unfortunately, even in 2016, we don't really have a really good model that predicts this particular collision. We don't really know how it happened. We don't really know where exactly the object landed, or how it actually affected the orbit of our proto-Earth. And we don't really have a good model for how the debris that was orbiting around Earth then combined into one single moon. And this would actually be called Moon now. And I think one of the main problems with this model is that you'll notice that even if you sort of continuously smack the object into the same region of the planet, it doesn't always create these orbits. Okay, this time it did. Actually, look at that. This is a almost perfect. Oh my God, this is awesome. There we go. Only after about 20 attempts, we've created a moon. And so yeah, it's maybe just because Earth got lucky. Maybe Earth got lucky and it created this moon that I currently have right here called Fragment, but we're going to name it Moon. And this possibly is because Earth got so lucky and it was just such a precise sort of collision that this is why we have our moon. Maybe Venus also received these collisions, and so did Mercury, but they weren't lucky enough to maintain or to keep these sort of fragments orbiting around them. And this is actually what I was waiting for. This is exactly what I wanted. So we have 2 moons. This is supporting the hypothesis that I spoke about before, where maybe there were 2 moons and then they combined after a while into one singular moon. And I think this is a pretty good representation of this giant collision hypothesis that said that at some point Earth received a collision from a Mars-like object, which I basically collided at 20 kilometers per second in this sort of region of space. And this created these orbiting rocks that and the thing is, the original moon actually orbited a lot closer to Earth. Its orbit was about 20,000 kilometers away. It wasn't really that far, but with time it did fly away farther and farther from Earth. And when this actually happened, when the two planets, Theia and Earth, combined, most of the iron from Theia stayed on Earth, and a lot of the debris, a lot of the rock and silicates with just a little bit of iron flew out and created these fragments that then became the moon. Now, this actually took me quite a while to achieve, and actually I'm really happy with what I have here, because it does actually kind of look like the original Earth-Moon pair that was quite likely similar to what you see here. So Earth, I think Earth would not be spinning that fast though, and this is actually, I think it's hours per second. Here we go, we can slow down this a little bit. Earth was very likely a molten body, so was the moon, and with time, obviously they both cooled down, and Earth started forming atmosphere, and the moon started to slowly drift away, combined with the second moon, and then basically started to cool down and became what we see today. Now I'm going to accelerate this a little bit just to see what Earth turns into eventually and what the moon looks like, because that's actually now is really interesting. It's very intriguing what we're going to create here after doing this for about an hour, trying to collide different planets into each other. So let's see what happens. And only a few days after, actually, it looks like the bigger moon started to change the orbit of the smaller moon already. Smaller moon has actually changed its orbital path, and so they either will collide with each other or will possibly cause some disastrous collision with Earth. And it looks like this smaller moon actually achieved a close to a circular orbit. Let me just take a look at it, see if I can maybe see it here. Alright, unfortunately it doesn't actually show in here, but it does look like an almost circular orbit, which is actually what I was looking for exactly. I was hoping to create a relatively large fragment, relatively close to Earth, maybe not this close, a little bit farther away, but in a circular orbit, and very similar to Earth in terms of composition. Because this is exactly what the moon is. It has a circular or a relatively circular orbit. It's similar in composition, and obviously it's much smaller than the Earth as well. But unfortunately, it's taking them way too long to cool down, so I'm going to cheat a little bit, and I'm going to actually lower their temperature manually. So we're going to change this to 0 first, and let's zoom into it and see what happens to our moon. So this is what happened to it as it cooled down. Its surface at first was kind of empty-ish. There were no craters here at first, but within the next few million years, it would actually receive quite a lot of collisions that would then define its sort of shape that we see today, and would obviously change dramatically from what you see here. Now let's zoom into Earth, and we'll do the same to Earth. We're going to go into temperature, change this temperature to 0, and this is the Earth as it cools down and acquires its shape we have today. And there we go. So we're going to turn Earth, and there you have it. Now it doesn't actually have any water in it. We're gonna add some water, and you'll notice that there's actually a very big crater here, right around here. There you go. There's a crater in this region. That's because of the collision with Theia. Now, this crater is possibly somewhere out there on our surface, but the thing is, because of the various geological activities on our planet, including volcanism and earthquakes, and because we do have atmosphere that sort of degrades the surface, all of the craters on Earth disappear with time. So even if there was a crater, a very large crater from the collision with Theia, it very likely completely is gone now. Moon, however, does still have them, because there's just not enough earthquakes and not enough geological activity on the surface of the moon. As a matter of fact, there's almost no geological activity on the surface of the moon. And because of that, Moon's craters actually do stay and don't disappear. As a matter of fact, nothing really disappears on the Moon. Even the early footprints from the early astronauts that visited the Moon are still very likely there. So here we go. We added some water, and notice how all of our craters have now become oceans. And so this is what Earth may have looked like early on in its history, 4.5 billion years ago, after the collision and after it cooled down, and when the Moon and Earth started to kind of stabilize and became these two partners orbiting around each other. And then slowly the Moon would drift away and would essentially just kind of separate from the Earth and orbit at the current distance of about 300,000 kilometers away from Earth. Now, the Moon 2 is still here, and I'm not sure if the Moon 1 and the Moon 2 will actually collide at some point, but let's just accelerate time and see what happens. They do have a point in orbit when they approach each other relatively close, So it's very likely that maybe Moon 2 will actually collide with Moon 1. But as I mentioned, this is of course just a hypothesis. We don't really know if there was really a second moon. We don't really know if this is how the moon was formed exactly. But just knowing what we know today, based on the fragments we found on the surface of the moon, and we have something like 300 kilograms of different fragments from the moon surface, and based on different asteroids we actually recovered on our planet Earth, and comparing them to the moon samples. We just kind of hypothesized that it's very likely that Earth and Moon have very similar structure. Earth and Moon may have been formed from a similar body, and because the surface of the Moon looks very different on the far side compared to the side that we see from our planet, it's also very likely that something very large at some point in Moon's history landed on its far side and then created these really unusual regions that we see today. Which is why a lot of scientists do think that this is how the moon was formed, and do believe that there were actually 2 moons earlier on. And anyway, so this is the nutshell of the giant impact hypothesis, and this is how I wanted to recreate this using Universe Sandbox 2. Unfortunately, our planet now froze over because we don't have a sun to warm us up, so the temperature on Earth will slowly drop dramatically. Hopefully you enjoyed this video, and if you did enjoy this video, don't forget to share it with your friends, and don't forget to like it as well. If you haven't subscribed yet, do subscribe, because there's a lot more science, space, and math videos coming in the future. And if you have any other ideas or recommendations, please post them in the comments below. Thank you so much for watching. I'm going to see you in the next video, and in part 2 of this video, we're going to talk a little bit more about the moon. We're going to discuss some of the cool facts about it, and we're going to explore its surface in Space Engine. Thank you, give me later, and bye-bye.